Okay guys, we're going to solve some more equations, so let's go ahead and get to it. Now here we go. So this is one of those where we have the variable on both sides, right? So we're going to subtract so that, to make it easier, we want to choose strategically to have positive variable just to make it simpler. So we have 3v over here, negative 6v over here. So you subtract 6v from both sides. Well, that's the same as adding 6v, right? It's negative over here, so we would add 6v to both sides to get rid of that negative. Does that make sense? Now, we're used to writing this underneath, so we would say plus 6v and plus 6v, negative 6v and positive 6v is 0. I'm going to do these different today. See what you think of this way of doing things, and I think for the students who are having trouble, it might make it more clear. It's the same thing. In fact, for this first one, why don't we just do it both ways side by side? So I'm just going to rewrite the problem over here. We're going to do this to make it clear that there's really nothing different in the method. It's just a different way of writing it. So we decided we want to add 6v to both sides. And the way we've been doing that, we would write it underneath. Tell you what, I'm going to do that in blue or red maybe. Let's use red. Okay. So plus 6v plus 6v. But the other way of doing it is to actually write it right in line. We'll go ahead and switch it to red. And on the other side, negative 6v plus 6v plus 24. So this is just a longer way of writing it, but you're showing exactly what you're doing. You're actually writing it in the expression that's on the left side of that equals sign. That expression was, and again on the right side of the equals sign. And I see that I did not make one of them red. Let's do that again. Erase that. Put it back in red. Okay. So rather than just write it underneath, we have rewritten it. We can see the black part did not change, right? So that shows we haven't made a mistake recopying. And we simply added 6v to both sides. We'll go ahead and make this red also. Okay. So perhaps this makes it a little bit more clear what's going on. Adding 6v to both sides, and to show it, we're actually rewriting the problem and showing the 6v added to both sides. So what's next? Negative 6 plus 3v and 6v is 9v. Here, negative 6v plus 6v is 0, leaves 24. Okay, so now what do? We want to get the v's by itself, get rid of the 6. So we're going to add 6 to both sides because this is a negative 6 that we want to get rid of. Okay, so that's negative 6. We'll change it to red, put in our plus 6. And then we still have plus 9v equals 24 plus 6. Okay, so negative 6 plus 6, that's 0. Leaves 9v. Over here, 24 plus 6 is 30. And now we're going to divide both sides by 9. And we're almost done. Over here we have v equals 30 over 9. Now you can reduce that, right? Because 3 goes into 30, 3 also goes into 9. So 30 divided by 3 is 10, 9 divided by 3 is 3. So that's the answer. 10/3. Okay. Now we didn't go ahead and finish this one. Let's go back and do that. This first one we'll do both ways. So at this point we would have said negative 6 plus 9v equals 24. Then we would have said, okay, we're now going to add 6 to both sides. And we would have said this is 9v equals 30. And then divide both sides by 9. And just about there. That gives us v. Whoops, wrong color. V equals 30 over 9, which equals 10/3. So that's the two ways of writing it. The steps were exactly the same. This takes a little more writing, but I hope it's more clear to some of you. So for this one, let's just go ahead and work through them in that manner. Okay, the next problem. Look at this. Always look, can you combine like terms? You got 4x here, you got 3x here. We got to combine those before we do anything else, right? 4x and 3x is 7x. On the other side, it doesn't change. Now we'll get rid of our x. So we're going to subtract x from both sides. 7x. I'm going to move my color thing a little closer so I can do it more quickly. Minus x plus 3 equals x minus x. And then this didn't change. It's still minus 21. Okay? So we're subtracting x from both sides, and we're actually writing it in line like this. Okay? Writing it out, you might say, rather than just writing it down below. So 7x minus x is 6x plus 3 equals x minus x, that's 0. Have negative 21. Now we're going to get the 6x by itself. We subtract 3 from both sides. 6x plus 3. Subtract 3 equals negative 21 minus 3. Okay. So on this side, 3 minus 3, that's 0. Leaves you with 6x. Negative 21 minus 3. Okay, so you're already at negative 21. Minus 3 means you keep going farther to the left on the number line. Minus 24. Okay, we're almost there. We're going to divide both sides by 6. And we get x equals negative 4. Okay. All right. Move right along. So this is one of those, first thing you have to do is distribute, right? You can't take 9 plus 2x. They're not like terms. Distribute. Then you'll be able to isolate the x, deal with the x's on the left, the x's on the right, and so on. So multiply this out. 27 plus 6x equals 5x plus 1. Okay. Get the x's to one side or the other. We'll subtract 5x from both sides. 27 plus 6x. Instead of writing it down below, we'll go ahead and say, move this over, minus 5x on that side, and that equals 5x and minus 5x on that side, and then the plus 1 is still there. Okay, so we just subtract x from both sides. It's just 27 plus x. 6x minus 5x is just x. 5x minus 5x is 0, so that equals 1. Okay, so now we're going to subtract 27 from both sides, right? 27 minus 27. This will get the x by itself. Plus x equals 1 minus 27. So that means 27 minus 27 is 0, just like we were intending. Leaves just x on that side, leaves negative 26 over there. We're done. Okay. So by now you might recognize what you have to do here. First thing, got to distribute on both sides, right? Okay. So we need to get the x's by themselves on one side or the other. So if we subtract 6x from both sides, that will take care of that. On the left-hand side, 16x minus 6x is 10x. Whoops, goes black. Still plus 20. On the right side, 6x minus 6x is 0. Just leaves you with the 15. We're almost there. Got to get the x's by themselves, so get the 20 to the other side. 10x plus 20. Subtract 20 from both sides. Equals 15 minus 20. On the left, just leaves 10x. Because 20 minus 20 is 0. On the right, though, we have 15 minus 20, okay? 20 is bigger, so this is like 15 plus negative 20, right? And the bigger one in magnitude, that is the negative one. So the answer is negative 5. Divide both sides by 10. Like that. Leaves us with x equals negative 5/10. Should write that in lowest terms. And that's going to be negative 1/2. It's also okay to punch it into the calculator, and that would give you a negative, well, I won't write it. Don't even need to write it down. Negative 0.5 if you put it in the calculator. All right. Let's see. Okay. Got 3 more. So this one, another one of those has to be distributed. Negative 12x. Negative 6 times negative 1. Be careful, negative times a negative is a positive. Negative x minus 4. Okay. Get the x's by themselves. Now, if we bring the negative x over to this side, we'll be adding x, but this will still be negative. So we might add 12x to both sides instead. Adding 12x, since this is a negative 12x, adding 12x will cancel it out. So we're going to say negative 12x plus 12x, and then plus 6 equals negative x, and both sides have to have the plus 12x, and the minus 4 is still there. Okay. So over here, negative 12x plus 12x is 0, leaving only the 6. Over here, you got negative x plus 12x. So that is 11x. Minus 4. I want to get the x's by themselves, so this, for subtracted, the opposite is addition. We need to add 4 to both sides. Oops. Okay, so on the left, it's 10. On the right, 11x. Last step, divide both sides by 11, right? And kind of running out of room here. I'm going to go ahead and continue right here. On the left, 10 elevenths. On the right, it's x. And that one is already in lowest terms, so don't have to reduce it. Okay. See what happens on this next one. We got something to distribute. 4 times 3x, 12x. 4 times 5 is 20. Okay, on the right side, leave it alone. Nothing to do over there right now. Look at that. We can get rid of the x's. If you're looking ahead, looks like something funny might happen. We need to get rid of this 12x or this 12x. Doesn't matter which one. They're both 12x. We'll subtract 12x from both sides. 12x minus 12x plus 20 equals 20. Oh, I kept writing in red. Plus 20 equals 20 plus 12x. And then subtract 12x from that side. Have to always subtract the same thing from both sides. Well, over here we get rid of the 12x. It's 20. Over here we get rid of the 12x. 12x minus 12x is 0. 20's left over there. We haven't seen one like this yet this year. Interesting, right? You end up with 20 equals 20. The other day we had one where you ended up with something that was false. This time you end up with something that was true. So what's going on here? Remember, every step we did was a good algebra step. We followed the rules of algebra. So we have equivalent equations all the way through. Whatever value of x makes any of these equations true makes all of them true, specifically the first one. So we have 20 equals 20. That's always true, right? There's no x's in there to even mess that up. So this equation's always true. Any value of x you use, it's still going to be true. X can't even change it, in fact, right? There's no x's even in it. So that means x can be anything. It's always true. Since x can be anything to make this true, that means x can be anything to make all of these true, including the first one. So doesn't matter what x is. We call that all real numbers. Okay, all real numbers are a solution to this equation. You can plug in anything. And then you can't tell that by looking at it up here, right? You don't realize you could put in 3 for x. You could put in 7. You could put in 132. You could put in 472,937.327948. Doesn't matter. This equation would be true. And so we say the solution set is all real numbers. And you can write that this way, sort of a symbol that means all real numbers. Looks something like that. That's another way to do it. Okay? Right? Let's look at let's see. We have just one more. Okay. This is another one of those where we have to go ahead and combine like terms. So we have 9x minus x. And so the left, you simplify as much as you can. You're combining like terms. On the right, still 4 plus 8x. Okay, we got 8x on both sides. I want to get rid of the 8x. Well, it's 8x on both sides. It's going to go away on both sides, right? 8x minus 8x plus 2 equals 4 plus 8x, and subtracting that 8x from that side as well. Okay, so on the left 2, and on the right the only thing left is 4. Now inadvertently we used this problem already. That's okay. It's kind of nice to see it again. I recognize this is one we did before, but it's nice to see it again and see it alongside the one we just did, where we got 20 equals 20, always true. This time we get at the end 2 equals 4. That's always false. And if you were in class the other day, you know we said, look, doesn't matter what you put in for x, that's always false. And since all of these equations are equivalent, they all have the same solutions, including the first one. If there's no value that'll make this last one true, there's also no value that will make the first one true. So there are no solutions. We can write it like this, or we could say this set, the solution set, is the empty set. It's a set which has nothing in it. So you can write it either of those ways. Okay, so that's a pretty good little bunch of practice. So that's all for now.